In this video, we're going to continue our lessons or our unit on polygons. And today we're going to talk specifically about a quadrilateral, a special quadrilateral called rectangles. Remember that quadrilaterals are four-sided polygons. All right. The thing that makes rectangles a special quadrilateral is the fact that the all of the angles in a rectangle in each of the four vertices are right angles. Right. So we have a theorem, theorem 613, that talks about the diagonals and then its converse as well. The diagonal of a rectangle theorem says that if a parallelogram is a rectangle, then its diagonals are congruent. So from K to M is congruent to J to L. The converse of that says that if we have diagonals that are congruent, then the polygon, then the parallelogram is a rectangle. Right, so pause the video and copy these two theorems into your notes. Alright, so we're going to do several examples. And so it says if AC is 3x minus 7 and BD is x plus 5, find AC. So AC is the distance from A to C, and BD is distance from B to D. Now, according to the theorem that we just learned about, those two diagonals are congruent. It means that they're equal to each other. So basically, to find the length of AC, we solve for x and then plug it into the equation for AC, 3x minus 7, and that'll give us the length of AC. So 3x minus 7 is equal to x plus 5. All right, so we solve for x. We're going to subtract x from both sides. All right, the x's cancel out on the right hand side. 3x minus 1x is 2x minus 7 is equal to 5. Add 7 to both sides. All right, we end up with 2x is equal to 12 divided by 2, and so x is equal to 6. All right, so now we just plug this x value right here into the 3x minus 7. So we're going to say 3x minus 7, right? So x is 6, that's 3 times 6 minus 7. 3 times 6 is 18 minus 7, which gives us a length of 11. All right, and if we just wanted uh, to verify that they are congruent, then we could plug it into BD as well. So here we have 6 plus 5, which is also equal to 11. Right. The next one says if AE is 3x minus 5 and CE is 2x plus 11, find AC. So AE is this part, that half. CE is this half. So now what this does, this comes back to our previous lesson where we learned about parallelograms, And one of the properties that we learned about there is that in a parallelogram, the diagonals bisect each other, or they cut each other in half. So what we can figure out from that is that AE is congruent to EC, right? So once again, and the thing that we're looking at here is AC. We're looking at the full length here, all right? But to do that, we need to figure out what our x value is. So we're going to go 3x minus 5 is equal to 2x plus 11, all right? We're going to solve for x, so we're going to subtract 2x from both sides. 2x's cancel out. We end up with 1x minus 5 is equal to 11. So we're going to add 5 to both sides. And 1x, or just plain old x, is equal to 16. All right? So x is equal to 16. So now we're gonna plug it into one of these two equations. I'm gonna plug it into this one. So I'm gonna say 2x plus 11. So that's 2 times 16 plus 11. Right? 2 times 16 is 32 plus 11, and we find that CE, this right here is 43. Well, we also, like we had found out, we noticed before that the two sides are congruent. So both sides of 43, and 2 times 43 is equal to 86. So AC equals 86. All right. If BE equals 4x minus 9 and CE equals 2x plus 5, find AE. All right. So when we look at this, okay, BE is it's right there. CE is it's right there. Now the thing that we notice about this one is that both segments that were given the equations for are on different diagonals. But according to the theorem that we learned about at the beginning of the lesson, it doesn't matter because both diagonals are congruent, and we also know that because they're parallelograms that they bisect each other. So we know that this length is the same thing as this length, and so they're going to be congruent. So we're just going to once again set them equal to each other. 4x minus 9 is equal to 2x plus 5. Okay. Solve for x by subtracting 2x. We're left with 2x minus 9 is equal to 5. Add 9 to both sides. 2x is equal to 14 divided by 2. X is equal to 7. Okay? So x is equal to 7. It wants us to find AE. AE is this right here. We know that AE is the same length as EC or CE. So we're just going to plug it into here. So this would be the 7 plugging into that. We could also plug it into the 4x minus 9, but because they're both congruent. So we're going to, but it does. I'm going to plug it into the 2x plus 5. Okay, and so that's 2 times 7 plus 5. It's 14 plus 5, and so CE is equal to 19. All right. This example talks about the measures of the angles. Okay, so remember these every angle here, each of the angles here are going to be 90 degrees. Okay, every angle in a rectangle is 90 degrees. So it says if the measure of angle CDB, CDB, that's this blue one here, okay, that's this one. CDB is 2x minus 3, all right? And the measure of angle BDA, B to D to A, that's this one, is x plus 12, okay? That's x plus 12. Find the measure of CDB. So we're CDB. So we're going to look at finding the measure of that. Okay. So what we know, the only thing really that we know is that both these angles, because they're on the same angle, that they're going to add up to 90 degrees. So we're just going to say 2x minus 3 plus, this is the first angle, plus x plus 12 is going to be equal to 90. All right. So then we combine our like terms. 2x plus x is 3x. All right. We're going to add, remember this is a negative 3. Negative 3 plus 12 is 9 is equal to 40. All right. So now we solve for x. We're going to subtract 9. Subtract 9. And we end up with 31. 3x is equal to 31 divided by 3. X is equal to 31 divided by 9, or 31 divided by 3 is 10.3. Okay? All right. So find the measure of CDB. So CDB is right here, which is 2 times x minus 3. And so 2 times 10.3 minus 3 is 20.6 minus 3, which is 17.6. Okay, so that's 17.6 degrees. All right. If the measure of angles BCA, BCA, that's this measure, this one right here, is 2x plus 7, DAC, and the measure of angle DAC is 3x minus 5. DAC, change colors here, DAC is that that angle right there, we have 3x minus 5. All right, so what we notice here, we notice that they're on the same diagonal, all right, but they're not talking about the same, vertex, all right? So one of the things that you'll notice that we can remember that'll help us solve this is that this is a parallelogram. A parallelogram says that opposite sides are parallel to each other. So in other words, we can look at this as this being a set of parallel lines with a diagonal that goes through those sides. And then if we look at it like that, we notice that this angle right here and this angle right here are alternate interior angles. Okay? Alternate interior angles, and we know alternate interior angles are congruent. Okay? So we know that these two measures are congruent. So we're just going to say, and I'm going to put this one on the left, it doesn't matter. 3x minus 5 is equal to 2x plus 7. Solve for x minus 2x minus 2x. Oops. This is actually 1x minus 5 is equal to 7 plus 5. X is equal to 12. All right. We're finding the measure of DAC. DAC. That's this one right here, which is DAC is 3x minus 5. So we're going to say 3x minus 5. That's 3 times 12 minus 5 because the value of x is 12. That's 3 times 12 is 36 minus 5, which is 31. All right, so the measure of this angle right here is 31, all right, DAC, which means that this measure up here is 31 as well. All right. All right. The next thing we're going to talk about is proving whether a quadrilateral is a rectangle or not, and we're going to go back to using that first, and we're talking about on a coordinate plane here, and we're going to use that first theorem that says that diagonals, if it's a quadrilateral, actually it's the second theorem that you wrote down, that says that if the diagonals are congruent, then it's a rectangle. All right. What I've done here is you've learned the distance formula in the past, but go ahead and it's been a little while since we've used it, so go ahead and copy this back into your notes so that you remember what the distance formula is. All right. So pause the video and do that. All right. Now that you've copied that distance formula into your notes, let's go ahead and determine whether the quadrilateral ABCD is a rectangle using the distance formula given these vertices. Okay, and if we're looking at it, this is A, B, C, D. So this is going to look like negative 3, 0. Well, A would actually be here. This up here would be negative 2, 2. C would be 3, 0. Well, no, it wouldn't. It wouldn't be up there. It'd be down here. And D is 2, 2. Okay. 2 or 2, negative 2. Wait a minute. Hang on. Hang on. Let me clear this out again. All right. So if we're talking about a coordinate plane, all right. So negative 3, 0. Let me just draw a real quick coordinate plane. Okay, negative 3, 0 is negative 3, 0. That's A. Okay. Negative 2, 2 would be here. That's B. Okay. 3, 0, 1, 2, 3, 0. That's C. And 2, negative 2 is here. That's D. Okay. So we're looking at something that looks like that. Okay. So it appears to be a rectangle, sort of at a slant on a coordinate plane. All right. So one of the reasons that we needed to draw it out like this is to know what the opposite corners are. So A and C are one diagonal, B and D are the other diagonal. And so what we need to do is we need to prove that AC is the same distance as B and D. All right. So AC, so we're going to do this and we're going to do this. So we're talking about the square root of x2 minus x1. So we're subtracting two x values. So I'm going to do 3 minus negative 3. And I'm going to square it. Plus the y value, subtract the two y values. That's 0 minus 0 squared, which is going to be nothing. Square root of 3 minus negative 3. I do this. So that's 3 plus 3 is 6 squared. Okay. Plus 0 squared. So this is square root of 36, which is 6. So the distance, so this is AC. Okay. Now, let's do BD. All right. So when we do that, subtract the two x values. So I'm going to say 2 minus negative 2 squared plus, that's 2 minus negative 2. And then I'm going to say negative 2 minus 2 squared. Okay? And when we do that, 2 plus 2, that's 4 squared, plus negative 2 minus 2 is negative 4 squared. 4 squared is 16 plus 16. Square root of 16 and 16 is 32. Here we had 36. Okay, so this would be, no, it's not a rectangle. Okay, we can see because the two diagonals are a different length. All right. All right. So next one, determine whether the quadrilateral is a rectangle using the distance formula if the vertices are at -1, 0, and once again I'm going to quickly sketch out, make sure that I would assume that A and C are diagonals and B and D are diagonals. But -1, let's see here. -1, 0 is here. 0, 2 is here. 4, 0 is here. And 3, -2 is here. So once again, and you know, this is just a quick hand drawn vertex. So this is A, B, C, and D. So we're talking about AC and BD. So when we do that, I'm going to subtract the two x values. I'm going to go 4 minus -1 squared plus, once again, I have 0 minus 0 squared. Okay. 4 minus -1. 4 plus 1 is 5 squared plus 0 squared. And square root of 25, which is 5. All right. Then let's do BD. So this right here is AC. Okay. All right. This is BD. All right. So we're going to subtract the two x values. That's 3 minus 0. 3 minus 0 squared plus -2 minus 2 squared. All right. 3 minus 0 is 3 squared plus -2 minus 2 is -4 squared. 3 squared is 9 plus -4 squared is a positive 16. So that's 9 plus 16 is 25. And so BD is equal to 5 as well. And so these two are alike. And so this is a rectangle. All right. And our last example is, it says find the measure of each of the angles below if the measure of angle 1 is 40 degrees. So we know that this measure up here is 40 degrees. All right. So if we know this is 40 degrees, we know this is a right triangle, or not a right triangle, but a right angle. So that means angle 2 has to be 50 degrees. All right. Angle 4, once again, remember these are parallel sides with a diagonal running through it. Okay, so these are alternate interior angles. So angle 4 is alternate interior, which is equal to 40 degrees. Okay, angle 3, well, we also know, remember, we also know that this diagonal, part of the diagonal, and this half of the diagonal are congruent. So what we have right here is that this right here is an isosceles triangle. And so we know that this is going to be, angle 4 is going to be congruent to angle 3 because the two base angles are congruent on an isosceles triangle. So that's going to be 40 degrees. Okay. And we know that all three angles are going to add up to 180 degrees. So if this is 40 this is 40, okay? 40 plus 40 is 80, so angle 6 has to be 100 degrees, okay? So this right here, okay? So 40 plus 40 plus x is equal to 180, okay? So this is 80 plus x equals 180 minus 80, and that's, so our known angle is 100 degrees, okay? That's this right here. All right, angle 7, we know that angle 6 and angle 7 form a straight line, so that means that's 180 degrees as well. So angle 7 is going to be 80 degrees. And angle 5, okay, angle 5 says that, and this is the trickiest, the little trickiest part, okay, we know that angle 5 and whatever this is going to be, are going to be the same, are going to be congruent. Well, we know that this right here, we've already figured out that this is 50 degrees. So that means this is 50 degrees. All right? All right, because these are all 2 and this unknown angle over here are 50 degrees. And so, uh, so that means angle 5 is also 50 degrees. Okay, so we went through a lot of different concepts in this particular lesson. So make sure that you ask me any questions if you have questions, and we'll talk to y'all later on.